Hey everybody, here we have this Compaq Presario desktop PC in for service, and what it needs is some upgrades. Windows is fine, and it has Windows 7, and it doesn't have any serious like infections or anything. It's just a real base model computer that's being pushed harder than what it was really designed for. The owner of this computer runs software called Cakewalk, and he has a musical keyboard attached to this computer. And he was telling me that when he's running his Cakewalk software, there'll be times when there'll be a big lag between the times they press the keys on his keyboard, musical keyboard, and the notes would come up on the computer. So I told him, just bring it on by, let me look at it. And there's two red flags right away with this computer for what it's being used for. First off, it's got an AMD Sempron processor in it. Of course, nowadays they don't even tell you Sempron. They stick an AMD logo on the front of the computer. And it only has 2 gigs of RAM with a 64-bit operating system. Normally, when computers have only 2 gigs of RAM, they actually install a 32-bit operating system, but you see, like Compaq and HP have went their own way and just installed 64-bit even on machines that only had 2 gigs of RAM, which in this case is going to be a good thing, which I'll explain why in a moment. Anyways, here to look at the specs. This is a Compaq Presario CQ5300Y PC, and it has the AMD Sempron LE1300 processor. Very basic processor. Only 2 gigs of RAM. This is DDR2. 320 gig hard drive and a DVD burner, and Windows 7 64-bit. It seems like with AMD Sempron setups, they use the older architectures in these setups. For example, way back in the days when socket 754 and 939 were out, AMD used the socket 939 setups commonly for the Athlon 64s, the X2, and the 64FX processors, while they commonly put the Sempron processors on the older socket 754 setups. Now, they did make some socket 939 Semprons. I do have a couple are laying around here, but back then they commonly used 754 for Sempron setups. And with this machine, of course, normally a 2010 machine, or at least a late 2009 computer, would have probably a socket AM3 setup with DDR3 RAM. Well, with this one it has a socket AM2 Plus setup, which is 2008 compliant, and has DDR2, which is of course compliant with the older specs. And I actually have a Toshiba notebook laying around that needs some work done to it, and it also has a Sempron processor in it. Now, I'm not very knowledgeable about the AMD notebook sockets, but I believe there are sockets newer than socket S1. This Sempron uses a socket S1 setup, but just put it this way, I got an older HP DV6000 notebook that's in non-working condition laying around. That was manufactured in, I believe, 2007. It has a Turion 64 dual-core socket S1 processor. So just to give you an example here, like I was saying, that Toshiba, which is manufactured in 2009, is using a 2007 compliant socket for its Sempron processor. Anyways, back to the point here with this computer. The good thing is about it, the motherboard does happen to have the new enough BIOS to support Phenom 2 AM3 processors. It may not support the AM3 Athlon 2 X4 processor or X3s, and of course it won't support the 6 cores. I mean, the motherboard's only rated for 95-watt TDP processors. Anyways, let's go and open this computer up and have a look inside. Okay, now you're probably asking, Nick, why do you have this computer facing in the wrong direction on the desk? Well, it's pretty simple. These HP computers have a different design on their cases, which is pretty smart, I believe, in my opinion. It's basically a micro ATX setup, but the motherboard is on the other side of the case and it's upside down. So that way the ports will be facing the rear of the system. Anyways, here's the reason why I like this kind of setup. Think of it this way. Heat rises. In most setups, you have your CPU located right about here, right below the power supply. And a lot of the heat is up in this area of the computer, while down at the bottom it's nice and cool. Well, in this setup, your CPU is stuck down here in the bottom of the system, so that way the cold air will be down in this area, so your CPU will run cooler because it's getting cooler air. And on more premium versions of these HP computers, they have the hard drives located here, but in this setup they put the hard drive here. So if you're ever looking to upgrade your hard drives or add in additional hard drives, you'd have to find you the cage that goes mounted right here. And of course, you have to replace your power supply with one that's over 250 watts, I believe. Anyways, let's have a closer look at this motherboard. Very basic motherboard. You can actually see where 2 additional DIMM slots could have been installed, but they didn't put them there. This is common on a lot of OEM boards like this. If you have a look at that CPU heatsink, it's very, very tiny. There's not much to it at all. Well, the thing about Semprons is they run very cool. I'd assume this CPU is probably a 45 watt TDP chip, so it doesn't put out much heat at all. And this motherboard here is based on NVIDIA chip, because the graphics on the front, the graphics sticker said graphics by NVIDIA, and this is a single chip setup. This motherboard here is very similar to what's in the Parts Home Theater PC, also known as the Q Computer TV box. If you look at some of the videos that you'll see a motherboard looks really similar to this, except it's a different color. Anyways, back to the point here. This system only has a single 2GB stick of RAM, and it's the typical OEM memory that comes in these computers. And let's go ahead and pull it out so I can have a closer look at it. Okay, here's the RAM out of the computer. It's a single 2GB stick of RAM. It's DDR2 800. Does not display the timings on it anywhere, so we have no idea what the timings are on this stick of RAM. And here's the new RAM that's going to be installed. It's a dual channel kit, 4GB of G-Skill memory, DDR2 800, and the timings on this memory is 555 to 15. And its G-Skill RAM should be a whole lot faster than that RAM right there, I believe anyway. And the CPU is going to be replaced with a Phenom 2 quad-core 905E processor. Yes, this is a 905E that I used to use in the Mid-Tower Deluxe way back when. I kind of hate getting rid of this processor, but at the same time, the Mid-Tower Deluxe is going to be getting upgraded pretty soon anyway. So I'll have another handy-down setup to use. And of course, this power supply is going to be getting taken out too. Not only is it only a 250 watt power supply, but this power supply does have some issues. I'll get onto that here shortly. Let's go ahead and do the upgrades right quick. Okay, I'm going to pull the heatsink off the processor so that way you can see the memory slots a little easier. Okay, since I've already removed the original stick of RAM, it's just a simple matter of installing the new sticks. And I can't stress it enough, it seems like upgrading your computer's memory is probably the easiest repair or performance upgrade you can do to your computer to make it run better. It's probably the easiest thing you can do. It's just a matter of popping in the new sticks. There's nothing to install. You just stick the RAM in there and you're done. And this is how you stick it in. That's one stick. And here is the second stick. All done. Now we've already got the CPU heatsink loose. We'll go ahead and take out the old processor. There it is. AMD Sempron. We'll go ahead and drop in our Phenom 2. Just drop it in. Do not force. It should just drop right in. Processor's installed. Now we'll go ahead and prepare to install the heatsink. First thing we'll do here is going to get our CPU nice and clean. And we'll do the same thing for the heatsink we're going to install. Of course, the stock heatsink in this computer was so tiny we needed to put one a little bit bigger than what was stock. Even though the Phenom 2 doesn't, this particular Phenom 2 doesn't run hot at all, it's still a pretty smart idea to go ahead and install a somewhat better heatsink. Now what we'll do is go ahead and use some Windex, and if you have isopropyl alcohol available, use that, because I mean it's also a fast evaporating substance, which I noticed that Windex, also known as ammonia-based glass cleaner, evaporates really fast too. Now I've used it plenty of times to clean CPUs and heat sinks and stuff. It does the job just fine. Just give it a good wipe down, it'll be fine. And do the same thing to the heatsink. Okay, everything's nice and cleaned up, and here is how I do things when I install thermal paste. I install thermal paste to whatever is smaller. In this case, let's say you have a big flat heatsink, and of course your CPU die, or your heat spreader in this case, excuse me. In this case, what you'll do is, since the heat spreader is smaller than the heatsink base, you'll apply your thermal paste to that. But let's say you're using a heatsink like this, and of course this right here is the location to where the CPU touches the cooler. Install thermal paste here instead of on the heat spreader, because this is the smaller contact area right here. But since we're using this cooler, we'll install the thermal paste to the heat spreader. And of course, when you're installing your paste, you don't need an extremely large amount of it. It don't take much at all. And of course, this little thing of thermal paste, the syringe is not very, it's not easy to work with. Sometimes it squirt out too much, but that's not too big of a deal. We're using this on a big heat spreader, so we should be fine. And next thing you'll do here is take your spreader card. It can be a credit card, driver's license, anything like that. Of course, this is a spreader card that came with a thermal paste kit from Best Buy years ago. Well, you can't really see what I'm doing because my arm's in the way, but anyways, what I'm doing is I'm spreading the paste out across the CPU heat spreader. Okay, good enough. I don't know if you can really see or not in the video, but let me go ahead and zoom it in a little bit so you can probably see a little better. There's the thermal paste on the processor. Now I'm going to install our new heatsink, which isn't really new. It came out of an HP computer, parts computer. Which, of course, if you have a socket 754-939 heatsink, which is what this is right here, it'll work just fine on a socket AM2 or AM3 socket, or retention bracket, I should say. Okay, it's installed. Now what we'll do is we'll go ahead and plug our fan connector into the motherboard. Never forget to do that. Okay, now that's done. Now the CPU is installed. And finally, we're going to go ahead and replace this power supply. This right here is the power supply that's going to be going in this computer. It is a Hypro 300 watt unit. Let's go ahead and pull that so I can show you the specs on it. Anyways, here's the spec sheet. Pause to view specs. Okay, anyways, this power supply has much better specs than the one that's currently installed in the computer. This is a 300 watt unit. Well, 305 watts is what it says, but of course, we'll just say 300 watt. And this power supply here is one that I repaired. I replaced some capacitors in, so it's ready to go. And let's go ahead and take this power supply out. Okay, I've already disconnected all the connections from the power supply. Now all I gotta do here is just unbolt it. And this power supply uses, well, the screws that HP loves to use on their computer sometimes really annoy me. These are torque bit, also known as, well, they're not actually hex screws, but they're kind of close to it. But you can also use a flathead screwdriver to get those out, which is what I'm going to do. Yeah, these screws here annoy me big time, and anytime I take them out, they go in the trash can. I install regular Phillips head screws. So it's going to take these out. And on HPs, there's a latch inside the case you have to push down on before you can actually pull out the power supply. Anyways, here's the old power supply. It's out. And I'll go ahead and set it to the side. I'm going to go ahead and install the hyper unit, which is much more appropriate for this computer than the Bestec that was in it. I'm not saying that Bestec is a bad supply, it's just it wasn't very appropriate for the hardware in this computer. Okay, here's 4 Phillips screws. And of course, take these originals and toss them in the trash. I have no use for them. They're annoying. Now, go ahead and install the screws to the power supply and plug in all the connections. Okay, the new power supply is installed with all the connections made, and the ones that weren't needed got tucked away. The memory is upgraded, the CPU is upgraded, and I'm going to talk about this power supply, but I'm going to put this portion in a different video because it talks about a whole different thing. Anyways, it's pretty interesting, so I recommend you go ahead and watch it. Okay, now let's go ahead and stick the cover back on this computer and start it up. Okay, now we're in Windows, and there is the new specs down here. See, it says AMD Phenom 2 X4995E processor, 2.5 gig, and has installed memory of 4 gigs of RAM, 3.75 usable because of internal graphics, onboard graphics I should say. And now we're going to go ahead and update the Windows Experience Index. And of course, there's the old one. Let's look at the scores that it originally got. The processor was only a 4.2. Memory was only a 5.4. And of course, the graphics and game graphics probably won't change, and also the hard drive score probably won't change too. So I'm going to refresh this. That was very fast. Processor score is now 7.1, and memory score is now 5.9. That's a big jump from what it was. So, see, the good thing about replacing the OEM memory with something like G-Skill really makes a difference. And of course, that CPU score is much higher than the Sempron that was installed in this computer. So, anyways, now this computer is a whole lot better than it was. And any questions or comments about this kind of upgrade, feel free to ask.